I'm Roger, and I want to share with you a little of the history of how Titronics ended up in the chiropractic instrumentation field. Going back to 1970, the first company was Titronics Inc. And at that time, I concentrated on putting together industrial control equipment for some of the companies here in Iowa City that did not have an electronics or an electrical engineering department. Some of the projects involved everything involved measuring temperature, flow rates. I love measuring things, and I love the sensors that pick up the signals that we need to do a function that controls a process. One of the projects we worked on, this was a flow metering system for the home foamers in Mount Pleasant, Iowa. They were pumping urea formaldehyde foam into the walls of homes that did not have insulation. We spent about a year and a half finding the right flow meters that would handle that material, and came up with a little DC motor and a valve that we went over 40 some different valves until we found one whose angular rotation was fairly linear with the flow going through the valve. So we made a control system that would monitor and record the formaldehyde and the activator, and the operator could balance the ratio, and this little motor would turn the valve and make sure that regardless of how high they were up on a roof or in a building, that the flow rate remained constant and eliminated the shrink and the stink which accompanied all these homes that were insulated that way. The formaldehyde would outgas over time, especially in the summer. This was another little control system we did for a local company that was manufacturing integral skin foam for armrest and dashboards for the automobile industry. And again, we would be measuring two different flows, and we had a little controller circuit board that we laid out and a motorized potentiometer. Originally, all they had to control with was a pot that someone had to turn by hand, and we found a nice little Swiss gearhead motor that would fit on that rheostat, and the feedback system would automatically control the flow rate and make a perfect foam. Sometimes when the ratio was off in cold weather or warm weather, the density of the foam would change. And what brought this on is that one of the top executives of Buick, 2 o'clock in the morning, the horn on his car came on and blasted away. And let me tell you, everybody heard about that the next day, including Titronics, which was asked to immediately put some controls on that line that was making the steering wheel foam area. So that's the background on some of the work we did prior to being introduced to chiropractic. Now I'm going to come over here to this other bench and show you the progression of instruments that led to the Titron. One of the projects we worked on that really involved measuring temperature in extreme environments was to come up with a control system for a roofing company in Cedar Rapids, Iowa, that applied the flat membrane roofs on stores like McDonald's and other stores that were welded with a hot air welding machine between the seams. The operators would sometimes go too fast. The roof seams looked like they were stuck together, and later on a high windstorm they would come apart, as they did on the courthouse in Kansas City. So we were called and put together a infrared sensor that was able to provide accurate readings from below zero to over 130 degrees in the summertime on a roof in Plano, Texas, which I had to be working on to see if our equipment would handle those extreme temperature ranges. And this was developed to monitor the temperature of the plastic membrane as the roof welder passed over it and completed the seam. I'm showing this because it was this sensor that was first used to build a prototype. So remembering that sensor that we developed for the roofing machine, a real quick background. I didn't know anything about chiropractic, but the little bit of time I was in grad school, which was very short, I hated graduate school. I like building things. And so that's when I started Titronics in 1970. I remembered the graduate students in the physical therapy program were always coming over into our area, to the engineering shop, and using a chart recorder to measure temperature on people's backs. So after the 5 or 6 years it took us to build a very accurate infrared sensor that would focus down to a small spot, I remembered that possible market, that maybe this could be used to measure temperature on the back. So I asked around, and someone said, oh, I think chiropractors do that, or some of them do. I found Dr. Myron Brown in West Liberty, Iowa, and called him and asked him if he had an interest in measuring temperature on backs. And what we found, I went to visit Dr. Myron Brown, and he was using the Dermatherm, which was a development of Dr. Pierce and Dr. Stillwagon. It was an infrared device, and it would also tie to a chart recorder, and Dr. Brown would scan his patients' backs and look for these chart recordings. I didn't quite understand why he was doing that. He was being mentored by Dr. Bud Crowder, and Dr. Brown got us together, and Dr. Crowder started to share with me BJ's work. Dr. Crowder had been in the clinic in the 50s and was a upper cervical specialist and was very used to instrumentation. Back at that time, they were using the NCM, which would measure the difference in temperature between these two sensors. If you've ever taken one apart, the two sensors were actually 7 pairs of thermocouples. And you can see all these wires that run back and forth to connect all those thermocouples in series so they would have enough voltage, enough current to run the needle on the meter that was on the face of the NCM. As I understood more and more about what chiropractic was and could do, I got very interested. I suggested to Dr. Brown that I could make his instrument more repeatable and more accurate. I took one of these home with me from his office, and I added, you can guess, I added our long barrel with a small bore to make it read just a very specific spot. Most infrared sensors, all infrared sensors, basically look out at a window like 60 to 90 degrees. And to measure a small spot, you had to be right on top of it, or have a focusing barrel and a lens like a culminator on the horses so they don't look this way or that way, and you can focus on a spot. So we added one of these barrels to Dr. Brown's device, changed some of the circuitry to make it more accurate, and brought it to him, and he was absolutely pleased. He said, now we need 2 barrels. I really want to look at both sides of the spine. And I'm looking at, this is a lot of work, but all right, we'll do this. I wasn't convinced yet about the philosophy or the theory of chiropractic, Dr. Brown came to my basement where we are right now, and we used this very oscilloscope in 1980. This is a storage scope, which means as a trace goes across, the phosphor screen will record and hold that trace even after it passes. So we took this device, which a friend of mine, Dr. Roy in Davenport, he's an engineer, had put together 2 of our roofing sensors in a box, and his son Keith put this together for me, and all of a sudden we had the Titron Thermal Scanner, and here it is. We were in my basement, this basement right here, and Dr. Brown scanned my back, and I recorded the difference on this oscilloscope screen, took a piece of tracing paper, traced the graph, traced the one line, and about 2 weeks later he came back to my house and we did it again. And that, oh, let me tell you, some lights lit up. Those 2 graphs were identical, exactly the same shape. I had worked at Temple University Skin and Cancer Hospital when I was at Cornell. I worked in areas measuring temperature and EMG signals. I never ever saw anything on the body as repeatable as these temperature graphs, which I learned later are because of the sympathetic nervous system being aroused, and in that fight or flight response, dermatomes on the skin go cold, and there is the graph that results, and I have graphs on me over 25, 30 years now, that when I am subluxated are identical in shape to the very first ones. That's when Titronics changed direction. We changed the name from Titronics Incorporated. We stopped doing any of the control work we were doing for other companies, as lucrative as it was, and concentrated on temperature scanners for the chiropractic area, and changed the name of the company to Titronics Research and Development. Started working with Sherman College. Dr. Brown had been an instructor at Sherman for some time, and we put together, this was our first prototype for Sherman College. We worked there with the head of research, who was looking for ways to statistically compare graphs to know how close a patient was coming back into pattern of subluxation, and he needed digital input so that his computer could look at these numbers. Dr. Myron Brown introduced me to Ralph Boone at Sherman College, head of research. At the time, Ralph Boone's doctorate was in microbiology, and he also worked and became a DC while he was the director in the research department at Sherman. Malcolm Stort was one of the students who was a computer engineer working and helping Dr. Boone on the statistical programs comparing graphs from patient visit to patient visit. And they wanted digital input so their computer program could just take the data directly from a scanner and analyze it. So, the first real Titron we built for Ralph Boone and for Sherman. It connected to a computer and gave them the data they needed in a comma delimited file that they were able to bring right into their statistical software and start doing comparisons on adjustments, different techniques. It became apparent that there was enough interest in this that we really needed to build a instrument that could be done in production. As you notice, this particular one did not have a barrel. It was the best we did very quickly at the time to get some data into the computer for them. So we improved and continued to work on building something that this is only 2 of these were built, thank God. They wanted to measure distance as well as temperature, so there'd be a 1-to-1 correlation between where on the back we were reading temperature and the distance as along the graph line. So just like any storefront that has a photocell that brings when you walk in, we used little photocells on both sides of the wheel, and we did a wheel with 40 some holes around the perimeter, which took quite a while on the milling machine to make. And then we had to get the wheel to follow the grooves in the spine as we rolled up, so we had to do some kind of a spring-loaded deal. And some of the contraptions that we had to come up with to make that work, as you can imagine how much fun this was. And actually it was. I enjoyed doing that sort of problem solving. So we ended up with the ability to follow the back, be close enough to read, good barrels, the circuit board inside that was a lot of stuff all in one place. Very tricky, hand wired. It took about 4, 5, 6 days to build this after we knew what we were doing. A long cable, and we connected to the computer, and it did quite well. It was about 1985, 86, Sherman College Lyceum of 1986. We tied this instrument to not only this screen, but to a little dot matrix printer. I should have gone with a thermal printer, but I wanted to save the doctor $7 over the cost of a roll of thermal paper versus adding machine paper. So Ron Gable, who is a physicist at the University of Iowa that worked actually with Van Allen, was a good friend, and he did all the machine code programming to take the voltage from the scanner and convert it and print it out on a strip chart on that little printer. And we first printed the left side of the spine, the right side of the spine, and then the differential. So picture this, Sherman Lyceum, 1986, had an audience of about 90 chiropractors, and I was up on the stage at the podium demonstrating this scanner doing a scan on someone's back, and I was so proud for 3 minutes. Well, that little chart recorder went, and everybody in the audience was very polite. The doctors, sat there very quietly, and I'm sure I explained how fun it was building all this, never thinking how valuable 3 minutes of time is in a busy office. The thermal printer would have had that all done in a matter of seconds. So that was our first learning experience about how valuable time is. From that point, we built 2 of these. I sold one to a lady in, I believe it was Colorado, upper cervical doctor, and we knew that there's no way to build these in production. They would have cost tens of thousands of dollars. So we took the circuit boards. Isn't that a cool little airplane? We took the circuit boards and all the adjustments for balancing the temperature readings and the ambient temperature were all done by hand on these little potentiometers. And I even had I put a beeper in so we could make a sound. It was, we redesigned the head of the instrument so that it could take, barrels would be inserted, everything would go together, and our first time we went to a DE meeting, I had about 2 hours before I had to go to the airport. We still hadn't figured out a cover for this thing. We had 3 little buttons on it, like a mouse, and desperation took me to Kmart at the time, and we got a steering wheel cover and some Velcro, and all of a sudden we had an instrument. We went to DE, and Dr. Myron Brown's one of his roommates from when he was at Sherman, Dr. Mitsu Shiakawa, saw this and immediately purchased 200 of the C2000s for Japan. The Japanese doctors then, and still are now, very, very scientifically oriented. They will not touch a patient without looking at the graphs. The C2000, around I think it was like 88, 89, we were being asked, please, make something a little more ergonomic. This was kind of tricky as holding this handle and pushing the buttons and getting all the way up to the occiput. Most of the doctors started holding it like this, and the graphing process was a lot simpler, especially with taller patients. So that brought us to wanting to do a more ergonomic handle. Dr. William Amalu in California really wanted us to have, he's an engineer as well as a chiropractor, he really wanted us to have something more Star Trek-y. And so we tried all kinds of handles. I took handles off of tape dispensers, everything I could find with a handle that would work right. Nothing quite fit, and we didn't have the funds to just go to an injection molding company and say, make a beautiful handle and do all the work for us. That wasn't an option. I don't mind admitting that the handle that best fit came off an Israeli Galil assault rifle. Okay, it kind of just aimed beautifully. So we took the handle off my rifle, and we used it to make a mold, and a foundry in Davenport, Iowa, poured us the handle. And once we had one, we used the machine, a very precise hacksaw, to cut that handle in half perfectly and put a half on both sides of this plate, which is used by the foundry to make sand castings. So once we had one made, we had 4, and we did this. This plate goes into a sandbox. Another sandbox is put on top. The sand gets hard and takes form. They take the top off, take this out, put the plate, the tops and the bottom back together, and pour 4 handles. That made probably the first 1,500, 2,000 scanners for us. It was a lot of work taking a casting and cleaning it up on the milling machine and getting everything right that fit. Doing the head of the scanner was even more difficult than machining the handle. No 2 castings, even from the same mold, are exactly the same. And so when you set up in a milling machine to perform all the operations that align everything perfectly, was a lot of work. that's when another friend introduced us to a company in Oregon that was willing to take the time for a small company like Titronics and put all the programming into a numerically controlled milling machine that now produces the handles perfectly to within thousandths of an inch, and heads. So all the parts of the scanner now no longer come out of my basement, but from a real precision facility in Oregon. So that is the progression from a roofing machine all the way through to Dr. Roy Rush's and his son's prototype through Sherman College, through the C1000, of which 2 were made. By the way, the doctor that bought this in Colorado, when we actually had the C2000s finished, I offered her to trade her one. She wouldn't trade back. She didn't mind the dot matrix printer, and she liked what she had. We tried again when we had the C3000, and again she said, I like what you built. So that crazy scanner that we built back towards the middle of 1980, in 1995, 2000 was still working. It's been a really lot of fun, I've got to say it, in the progression of doing, keeping up with the interface to the computers that went from simple USB ports, simple serial ports to USB ports. The first scanners that we built actually had to have an interface card that plugged into the very first IBM computers. One of the times that I was working with Dr. Myron Brown in the beginning, the computers were $7,000, and I knew the graph was the key and the most important thing. So I tried building a small chart recorder using a gearhead motor out of those machines that give you your money when you put it in change, and it spits your dollar bill out or reads it in. That's the motor that does that, and we tried making a little chart recorder, and very shortly, as the prices of the computers came down, we didn't need to worry about chart recorders anymore, and everything went digital. So that's a little history of how Titronics research and development got into the chiropractic field. And I must say, as I read case studies every week from Dr. Tom Forrest, and how chiropractic can affect some of the most serious, what, as Dr. Palmer would say, diseases. I am just blown away. It's the best kept secret in the whole world, and it's such a shame. More and more of the students are instrument oriented and cervically oriented. The techniques out there for full spine and cervical adjusting are just getting more precise and more effective, with all the doctors that are doing seminars and the schools that are bringing outside doctors in with lots of experience with instrumentation teaching. I'm excited, and it's what a wild and wonderful profession. Thank you.